you ever stopped to wonder just how powerful the sun really is? Imagine a gigantic nuclear reactor, ceaselessly blazing in the heart of our solar system. That's our sun, a natural marvel, producing energy on a scale that is almost impossible for us to comprehend. This fiery ball of gas, about 109 times the diameter of Earth, is responsible for the existence of life as we know it. Every second, the sun generates an incredible amount of energy, equivalent to billions of nuclear bombs. This energy is produced through a process called nuclear fusion, where hydrogen atoms combine to create helium. This process happens in the sun's core, an area of extreme heat and pressure. Here's a fun fact. The core of the sun reaches temperatures of 15 million degrees Celsius. At these unimaginable temperatures, hydrogen atoms move so fast that they collide and form helium. When this happens, a small amount of mass is converted into energy, following the famous Einstein's equation, E equals mc squared. This process releases a massive amount of energy, which travels to the sun's surface and then radiates into space as sunlight. The energy produced by the sun is so vast that in just 1 second, it generates more energy than humanity has used in its entire history. Consider that for a moment. The energy we've used since the dawn of civilization, from the first fire lit by early humans to the electricity powering our cities today, is less than what the sun produces in a single second. Through its ceaseless nuclear fusion, the sun provides us with light and warmth, powers the photosynthesis that produces our oxygen, and drives the weather systems that water our crops. It's a constant, reliable source of energy that has fueled life on Earth for billions of years. So the sun, our very own celestial powerhouse, is responsible for the life and energy we experience on Earth. But how does this energy make its way to Earth, and what happens when it arrives? You may wonder. Well, let's embark on this journey together. Picture the sun, a blazing ball of hot gases, emitting a continuous stream of light and heat. This energy, traveling at the speed of light, takes approximately 8 minutes to traverse the 93 million mile abyss that separates us from our closest star. This journey results in what we know as solar radiation. Solar radiation is the primary source of Earth's heat and light. It's the driving force behind our planet's climate and weather patterns. As the Earth spins on its axis, the sun's rays strike different parts of the world at different angles, creating varying temperature zones. This differential heating results in the creation of wind, the evaporation of water, and the formation of clouds, all integral components of our weather system. Moreover, the sun's energy plays a pivotal role in the phenomenon of photosynthesis, the process by which plants convert sunlight into chemical energy. This chemical energy is then used to fuel the plant's activities, and by extension, the activities of the animals and humans that consume these plants. In essence, life as we know it is solar-powered, but it's not all sunshine and rainbows. While sunlight is essential for life, too much of it can be harmful. The sun also emits ultraviolet rays which, if not mitigated by our atmosphere, can cause skin damage and contribute to global warming. It's a delicate balance that our planet has mastered over billions of years. So the sun's energy, traveling across the vast expanse of space, arrives on Earth, warming our lands, driving our weather, fueling life, and maintaining a delicate balance. The sun's energy, then, is crucial in driving our planet's weather systems and supporting life. Now imagine if we could harness this immense power of the sun for our use. Well, the good news is, we're already doing it. The concept of solar power is not new. It's been around for decades. And it all starts with those shiny panels you might have seen on rooftops or sprawling across fields. These are solar panels, or more technically, photovoltaic cells. Photo is Greek for light, and voltaic is named after Alessandro Volta, a pioneer in electricity. So basically, these panels convert light into electricity. And it's not just any light, it's sunlight, the most abundant source of energy on our planet. Now, how does this conversion happen, you might ask? Well, each solar panel is made up of many smaller units called solar cells, usually made of silicon, the second most abundant element on Earth. When the photons, or particles of light, from the sun hit these cells, they knock electrons loose from their atoms. This movement of electrons is what we know as electricity. So in essence, solar panels are capturing sunlight and turning it into usable electricity. Brilliant, isn't it? But the benefits of solar power go beyond just electricity generation. It's a renewable source of energy, meaning we won't run out of it. Well, at least for another 5 billion years or so, until our sun burns out. It's also clean and produces no harmful emissions or pollutants. Unlike fossil fuels, solar energy doesn't contribute to climate change or air pollution. It's also becoming increasingly affordable, thanks to technological advancements and economies of scale. Moreover, solar power can be harnessed anywhere the sun shines, making it an excellent solution for remote or off-grid locations. It's a way to empower communities and increase energy security. So the next time you bask in the warmth of the sun, remember, it's not just a giant ball of hot gas, it's a colossal powerhouse, and we're getting better and better at tapping into its immense potential. Harnessing the sun's power could be the key to a sustainable future. However, the sun's power is not always beneficial. It can also pose some serious threats. As much as we celebrate the sun for its life-giving energy, it's important to remember that it's a double-edged sword, with the potential to harm as well as heal. Take, for instance, the effect of the sun's ultraviolet rays on our health. These invisible rays blister down on us, often without us even realizing until we're sunburned. Over time, frequent and prolonged exposure can lead to more severe health issues. The most notorious of these is skin cancer, which affects millions of people worldwide every year. The sun's rays can also cause cataracts, a clouding of the eye's lens, leading to blurred vision or even blindness. But humans aren't the only ones at the mercy of the sun's darker side. Our technologies are also susceptible. Imagine, if you will, a massive ejection of plasma from the sun's surface, a solar flare. These flares send out a burst of radiation across the electromagnetic spectrum, from radio waves to X-rays. When this wave of charged particles hits the Earth, it can create a geomagnetic storm powerful enough to disrupt our communication systems. This isn't some far-fetched apocalyptic scenario. It's happened before. In 1859, a solar storm known as the Carrington Event caused widespread telegraph system failures. In modern times, with our dependence on technology greater than ever, a similar event could have catastrophic consequences. We're talking about blackouts, satellite failures, and disrupted GPS services. The economic impact would be tremendous, running into billions of dollars. So, while we harness the sun's power for our benefit, we must also respect its potential for destruction. It's a delicate balance, a dance with nature that requires our utmost attention and care. As we move forward, we must continue developing strategies to protect ourselves and our technologies from these solar threats. The sun's power, like all good things, comes with its own set of challenges. But by understanding these challenges, we can better prepare for them, ensuring that we continue to reap the sun's benefits while mitigating its threats. So, what have we learned about the sun's power? Well, we've discovered that the sun, our very own celestial powerhouse, is an unending source of energy. It operates on a scale that is simply incomprehensible to the human mind. At its core, the sun is a nuclear fusion reactor, where hydrogen atoms combine to form helium, releasing energy in the process. This energy, in the form of light and heat, travels 93 million miles to Earth, making life as we know it possible. The sun's energy doesn't just provide us with daylight and warmth. It's also responsible for driving the weather systems on our planet and powering the process of photosynthesis, which is essential for plant life and the oxygen we breathe. It's not an exaggeration to say that the sun is the lifeblood of our planet. We've also explored the potential of harnessing the sun's power. Solar energy is a clean, renewable source of power that could significantly reduce our dependence on fossil fuels. The technology for harnessing solar energy has been around for decades and is continually improving. Solar panels, solar water heaters, and solar-powered vehicles are all examples of how we can tap into the sun's power. The challenge lies in making this technology more affordable and accessible for everyone. But let's not forget, the sun is a double-edged sword. Its power can also be destructive. Prolonged exposure to the sun's ultraviolet rays can lead to skin cancer, and solar storms can disrupt communication systems and power grids. It's a reminder that while we can harness the sun's power, we must also respect it. Indeed, the power of the sun is both awe-inspiring and humbling, a constant reminder of our place in the universe.